stage launch a task. They're both open. They're both long running. Okay, so that's really the only difference. Okay, it's just this parallelism of these tasks. Okay, so what happens in the previous results? You have a Bell snapshot drawn vertically. Okay, you've got tasks that might be available. The tasks have a precondition, so pretty much are guards. They have a postcondition. Okay, so it might be that the task says, well, if it's a hardware part, then the profit margin will be somewhere between 5% and 20%. That's the kind of postcondition we might have in that game. Okay. Now, what happens is, at a given step, you test the preconditions to see which tasks might be eligible. Okay, it may be that 2 of them are eligible, say, or some number are eligible, some not. We non-deterministically pick one, okay, and we execute, okay. And once we execute it, then the task postcondition, okay, helps characterize the set of possible snapshots over there, okay. And okay, so clearly there's no parallelism. And oh, by the way, what the results tell us is that for this kind of setup, verification conditions expressed in kind of a first-order LTL hybrid can be checked in p-space. So that's the basic result that is already existing for this setup. Okay, so you talk about runs of these snapshots where each step is a step done by one of these tasks, satisfying the close conditions. Okay, and you're working with this dense linear order, and then you have an LTL first order formula that you write down, and then you can test whether that LTL first order formula is always satisfying for all runs. Okay, so those are the previously established results. So what I want to get at is, how are we going to somehow reduce to those results? Okay, and so the setup is now we've got some Bell snapshot, and there's a little more complexity with our stage status. We've got this external event coming in, and we're going over to this new Bell snapshot with all the ripple, so all the micro steps in there. Okay, and the fact of the matter is we've got in our back pocket this formula phi, okay, which characterizes essentially which generated events and which follow-on things are possible. So now, so you can think of phi as a single service from the previous results. Think of phi as just one service which is characterizing, the preconditions on phi are pretty much, one of these events has come in, and the postcondition is characterizing, for each type of event that could come in, okay, and given whatever you've got, what could happen over there. So with the previous services, it's call a service against the world and have the world come back with some answer, which may be non-deterministic. Here, my service is, what does it take to do one macro step? My service is, there's this essentially non-deterministic event from the world. That's where the non-determinism is coming. Note that this might be the response of one of my service calls, right? I might have done a service call over here, and then eventually when I get to here, I get the response to the service call. So there may be in the payload, there's non-determinism, okay? So then, quote, my service right now is just, what's it take to do this one macro step? It turns out that the formula phi, satisfies the conditions from the previous results. Okay, any questions? Let me just, yeah.
So the macro steps are deterministic.
They are.
So a fixed input snapshot.
If this is fixed and the payload, if this payload is fixed, yeah, then it turns out it's deterministic. But you get a lot of non-determinism in how the event comes back, the payload of it, because that really corresponds to human judgments that were made Okay. So each macro step is like a single sequential task from the previously established results. Okay, and so now then what we do then to do this, to do our verification is we do, essentially we take the GSM model and we kind of rewrite, or we turn the crank to automatically come up with this fee. Now I'm working with the sequential model. Okay, and now I can just apply the previous results. Okay, so in essence, the GSM verification algorithm is, do this rewriting, now use the previously established techniques, and now you're done. Okay, so almost done. So let me just say this. Oh, okay. So high-level philosophy here. The business entity framework that's been used really since 2003 at IBM is showing its value in many ways. Okay, there's a sweet spot which is using it to cut across silos. We actually use the phrase upper middleware sometimes for that inside IBM. Okay, so it's really a cross-silo overlay. That seems to be a place where business entities give value where nobody else, the BPMN and all these other things, aren't giving value yet. So it's kind of a sweet spot for the first application of these ideas. Now, when we think about guard stage milestone, one thing it does is it kind of actually scans from traditional prescriptive BPM also over to the much more ad hoc style of business operations management found in case management. So actually GSM spans BPM to case management. Actually, it has very broad coverage. So it seems like a good framework to be studying. And then, being declarative, it holds the promise, not that we've really worked it out, of supporting variation, maybe regional variations, supporting evolution of your business schemas, of your business processes, integration, and et cetera. So we kind of feel that with GSM, we're really at the beginning of, beautiful new research. And, so it's going to give us the opportunities here to, study in a lot of directions. Like one is, what's the analog of the entity relationship model? Are milestones and scenarios really the basis of kind of an ER-like thing? How can we make the GSM easier to grasp, easier for people to understand? How do we implement it efficiently? What if we have scale issues? What if these are really, heavily used business processes? And then from a foundation level, this is involving mappings. This is involving verification. So that's very good. We're really allowing to ask many more pragmatically useful verification problems, and then optimization, issues. Okay, so let me stop. Thank you so much for your attention. Happy to take more questions.
Great. Why don't we thank the speaker officially? Those who need to leave can leave, and then maybe we can hang around for a little while longer. So Rick, very interesting talk. Thank you so much.